ரெக்கார்டிங் ஸ்டார்ட் ஆயிடுச்சுல. ஸ்டான்லி ரெக்கார்டிங் ஸ்டார்ட் ஆயிடுச்சு.
ஆயிடுச்சா?
ஆமா.
ஓகே 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 ஃபைன்.
பட் என்னோட லோக்கல்ல
ஓகே
ஸ்டோர்
ஃபைன்.
ஆகும்னு நினைக்கிறேன். என்னோட லோக்கல்ல ஸ்டோர் ஆகும்னு நினைக்கிறேன்.
பரவாயில்ல. அது நம்ம அப்புறம் அப்லோட் பண்ணிக்கலாம்.
ஓகே ஓகே சரி ஓகே.
ஓகேங்க, நீங்க பாத்துங்க. நான் இன்னொரு பிரிட்ஜில் நான் ஜாயின் பண்றேன். சரிங்களா?
ஓகே ஓகே
ஓகே ஓகே தேங்க்யூ.
Anyway, we have less people in our batch.
Okay.
I think we have less people in our batch compared to the batch.
Yeah. Okay. So we are going to talk about networking. So this is the most important we covered under the NUTANIX training. We see one by one. So manage and manage type and then research implementation, different load balancing and network segmentation. Okay. So in NUTANIX we have we get the VM, right? So same we say we actually say VM network. Okay, we say VM network. For different VMs, we create different VM network. So with the name of VLAN 100, VLAN 200. Okay, so I mean it is similar like what we create in VMware. We create in HPVC network. So depends upon the VLAN. We have different VLANs. We have to create different VM network. Okay, so this VM network is actually has a concept of managed and unmanaged. Give me a second. So we have two different networks. Okay, so one is managed and second one is unmanaged. So in managed, we have two different configurations. So question will be like, are you going to create a managed VM network or unmanaged one? Okay, so the difference between managed and unmanaged. So managed in the sense it enables IP feature. You know what IP is? IP address management. Okay, it is similar like it is DHCP server. Okay, so DHCP. So if you create VM managed VM network, when you create a VM, you select this VM network and it automatically assigns the IP address. Okay. Automatically assigns the IP address. You have to provide the range here. Okay, range needs to be provided. So if you provide the range, and we can it automatically takes the free IP and assign to the specific VM. Okay, and it takes the very first IP it takes as the DHCP server IP. Okay, because it's going to be act as the DHCP server, so as server provides one IP, right? You have an option to open this IP because it automatically picks one. But if you wanted to change that IP to a different IP, you have that option over radio. Okay, so unmanaged is the even you automatically you can now understand how the unmanaged works. So if managed provide IP automatically, then unmanaged it is the manual way of providing the IP address. So you can just map the VLAN by selecting the port group. Assigning IP address is manual. Okay, so that's the difference between unmanaged and managed, unmanaged and managed. So managed, it automatically assigns the IP address, okay, with the help of IP feature. So if you log into a portal, so if you come to VM, there you have network configuration. If you select this, you have option to create network. Okay. So here you can say, for example, VLAN 100. Name is 100. The VLAN ID is 100. Okay. If you check this option, enable IP address management, then it's going to be managed network. Okay. You have to set your IP address prefix length, gateway IP address. Okay, and then you get you come down, it will ask you further details. So here you have to provide the range. So for example, if you go with 0.100 and the end is 200, okay, then it picks free IP from this range and it assigns to the VM. Okay, we have an option to override DHCP server. If you see this, so the DHCP server is highest allocated. So the last IP it actually picks, but you have an option to override the DHCP server IP. So if you want to give your first IP, you can keep that first IP as your DHCP server IP. So if you provide that IP, you can ignore that IP from here. Okay, so probably you can start from 101. Okay, so this is the 100 hyphen managed. Okay, you can switch. Let me setting. I can uncheck this. I can uncheck this. Okay. So next, we are creating unmanaged. We learn to 100 unmanaged. Okay, we just enter the VLAN ID. Save. Click save. Okay, so these are the differences between managed and unmanaged. We know other differences for the two networks. Okay. Um, now we have created the network configuration. So then you can create a VM. While creating a VM, you can create the network name. Okay, so you can pick which network you want to go. You want to go managed or unmanaged. Okay, if you select the managed, okay, then you don't get this option. But since it's a community edition, we have this field, this field. But when you are working on the production, you don't get this field open, okay, because it automatically picks the IP from the range, so you don't get option to enter the IP address manually here. Okay. Since this community edition, so we have some work here, but technically it works it works the way I told. Okay, we don't have any images because yesterday we have destroyed this and have created, so we don't have any iOS images. So we are not going to create a VM here today, but I'm just so this one way you can manage it VM network, but then you can go to network. Okay. Here you can see your all your virtual network. Okay, so you also get an option here to create, but community edition we are not having that. Okay, you will get an option to create your managed and unmanaged network here. Okay, so that's one area. Okay, so this is from the this VM. Okay, then moving to the next side, we are going to talk about host network. Okay, consider we have two interfaces connected to every server. Okay, so I told for API we have separate connection, separate adapters. Okay. Okay. So we have three servers or three nodes, and every node we have two different interfaces. Okay, so this is for IPMI. Okay, this is separate switch for IPMI. Then we have something called data. So we actually define this out of time, and we have something called data. Okay, so in every server we have default we have two interfaces. Okay, the redundancy purpose. And one connected to switch one. So this is switch one, and this is switch two. Okay, so server one we have one interface that gets connected to the switch one. In server two we have second interface that goes to switch two. So same apply to all the servers. One interface will be connected to switch one, and another interface will be connected to switch two. Okay, why we have this? Okay, so to provide the residential fault tolerance. Okay, so consider if this switch go down, then you still have the switch up and running, and it is connected to the same server. So this your data transfer works. Okay, even if this adapter goes down, this cable goes down, we still have the second link up. Okay, so how do you plan your network? So that's the second question, right? How do you plan your network? Okay, so when you buy server, so what you do is consider if this is your server. Okay, so this is your server. So okay, I told you have to do interfaces. Okay, the recommendation would be like I told two interfaces, and you bought one single interface, a single adapter, okay, single adapter, a single card with the dual interfaces. In a single card, two interfaces. Okay, so if the whole the card, okay, if the card goes down, so then you need two interfaces, correct? So to avoid this problem, what they do is they buy two different adapters, okay, and each are having dual interfaces. Okay, so if this interface goes down, if this adapter goes down, you should have this adapter. Okay, so consider this design. Okay, so consider I have server which has this is your adapter one, then you have second adapter where you have dual interfaces. So total you have four interfaces. Okay, then you have a switch, two switches for the redundancy, and what you do is you take one interface connected to this switch, and then another one connected to the another switch, and here like this, and it goes like this. Okay, so this is I mean, we are providing the switch adapter level. Okay, so this one adapter goes down, consider. Okay, so you lose one connectivity from this card, and I mean, you use two adapters before in a different way. Okay. So I just give a high level view of architecture. Okay. So this is one server. Okay, and in this server you have two virtual switches. That was switch one, and we call it call it internal switch. Okay, we have something called second switch. So this is external. Okay, external switch. So default you get two switches. Okay, created during the foundation. Okay, we are manually creating these two switches. These two switches are created by foundation. Building the foundation, switch. Okay. So on top of the switch, you have all these switches created at the hypervisor level. Okay, and then on top we have something called CVM. Correct. We have CVM. So this CVM has two interfaces. Okay, virtual interfaces. Okay, and we have a host here, and this host has two vSwitches, and then we have some uplinks or physical address on the node. Okay, these are physical adapters or interfaces. Okay. So consider for now we are going to interfaces. Okay, and then we have two switches, two physical switches. Okay, so one interface connected to this, probably can take it as E0 as 1, then E0 as 2. Okay, this connected to the switch. Okay, so now in VMware we have port group. Then for that port group we will have for the switch we have the uplink. Correct. So for this switch, these two interfaces are uplink. Okay, so now consider we have a CVM. CVM has two interfaces, and one interface is connected to the virtual switch, and another interface is connected to the external switch. Okay, and purpose of this internal switch connection. This is where this connection is for storage communication. Okay, so if it is ESXi, your hypervisor is ESXi, then NFS protocol will be chosen for storage communication. If it is AHV, then ISCSI. If it is hypervisor, then SMB. Depends on the hypervisor, the protocol will be chosen. Okay, and what is the purpose of this? In this communication, only hypervisor and CVM communicate with each other. Okay, so I told you use case. Okay, I'll take another diagram. Recall. Okay, I told you a scenario. We have CVM and then we have a couple of VMs scenario. Okay, and then we have hypervisor. Okay, so your VM sends the IO request to hypervisor. The hypervisor has no connectivity to the storage. This is your storage adapter. And then you have a couple of disks. Okay, so hypervisor has no communication to the storage adapter, so it has to forward the request to the CVM. Right, this communication only I'm talking. So this is the storage communication. Hypervisor receives the that I1 needs to be redirected to the CVM, right? So this is the storage communication. Okay, and this storage communication is, there is a protocol. Okay, in FS, if it's XI, okay, ISCSI, AHV, then SMB for Hyper-V. Okay. So this communication is very important because this handles the storage. So if this communication goes down, hypervisor will be able to talk to your local CM. So this connection hypervisor, we have something called internal V switch. On this internal V switch, this hypervisor and this CM is connected. So with this, it establishes I2C communication. Okay, then once the CM receives the request, it might to storage adapter. Okay, so you remember this concept, Faiz? Do you remember this one? You are mute, Faiz.
No,
Okay, so are you clear with this, or do you want me to explain more detail? If you have any question, just let me know.
no, I'm good.
Okay. Do you want me to
Yeah.
explain?
I'll-
Okay. So, so this is how the communication works in NUTANIX. Okay, so in this environment, I mean, hypervisor itself can talk to the storage adapter. In NUTANIX concept, we have CVM text privileges, so it can only talk to the storage. So hypervisor need to forward all the requests to the CVM. Okay, so this communication is storage communication, and there is a protocol for storage communication. Depends upon hypervisor, the protocol will be chosen. Okay, and for to establish this communication, this internal switch is required. Okay? This internal switch. Okay, this is the internal V switch. This is very important for the storage communication. And if you see, this virtual switch has no uplinks. When I say no uplinks, it is not connected to any physical adapter. In a server, you have adapters where you connect cables, network cables, right? So you don't attach those interfaces to the virtual switches, internal virtual switch. Have one-to-one internal virtual switch, but I mean, you should not patch this switch. You don't make any configuration of this switch. That's the recommendation by NUTANIX. Okay. Default, you have two switches, one for internal, one for external. Okay. So in internal, we have one switch here. This is only for storage communication. With this switch, hypervisor and CVM, they talk to each other. Okay. So we said that storage communication between hypervisor and CVM, the protocol is chosen, correct? But if this is a protocol, then there is also IP address, right? Yes, it uses the internal range 192.168.510. This is a subnet. It is used for this local communication. So 192.168.5.1 will be chosen for your hypervisor IP. Okay, then 5.2 is your CVM, this interface IP. Okay, so if you want to relate this VM in VM, create VM kernel port group, right? To create VM kernel port group, you have to provide the IP address to that port group. So this 5.1 on the hypervisor, right? This IP is as the hypervisor. So hypervisor gets the kind of VM kernel adapter. So in VMware, we say VM kernel adapter, but here we say tab port or something. I mean, not tab port. I think I forgot the name, but there is a different port available for this. So where we assign this IP address. Okay. So 5.1 gets assigned at the hypervisor level. 5.2 will be assigned to this in this particular interface. Okay. So I wanted to show you this on the lab. Okay. So what we do is now we open the Proteus. Okay. So 92.168.172.30.141. So I have 141 Okay, so 151 is my hypervisor IP. Okay, okay. So you see here NUTANIX HP hypervisor. I'm logging to my hypervisor. Okay, so HP is a cluster optimized hypervisor. I have not connected to CVM. Okay, so now I took access. I took SSH to my hypervisor. Okay, so now what you can, I said is run IPA. Okay, see here 192.168.5.1. So this is a virtual 0. Yeah, so because the interface, and then we, so this interface, we have virtual bridge, we have the 0 and it has this IP. Okay, so I also told the next type for .2 is assigned to the CVM, and this particular range both CVM and hypervisor talk, right? So let's try if we can ping 192.168.5.2. Are getting right, correct? So next, what we do is we try to take SSH to this IP. NUTANIX at 190.168.5.2. Okay, it is asking for the password. So see here, it is changed to this CM. Okay, NUTANIX controller VM, and now it is connected to the CVM. CVM IP is now 192. It is 142, and it changes to the public IP. The 142 is the public IP, and the 192.168.5.2 is the internal IP. Okay, and from host you can use internal IP or this public IP to access your CVM. Okay, I can tell you a scenario. Some cases, if you are not able to reach your CVM, okay, because CVM is running inside the host, the public this IP for some issue you are not able to reach this IP. Okay, then what you can do is you can log into your host and using the internal IP and check whether you are able to connect to the your CVM on the internal network. Okay, so this is another way you can take SSH to your CM. Okay, you can also use this public IP to directly log into the your CVM, or you can log into your host and then you can use the internal IP to connect to the CVM. Any question here? Do you have any question? Okay. So next, okay, so we have this virtual vSwitch size. Right? We are not going to touch anything on this switch and don't do any changes on this switch, because any changes will put this link to down, and if this down, if this link goes down, then this host, I mean, Windows cannot read and write the data on this local node. Okay, so it can be a CVM issue, or it can be a Stargate, or it can be this link status. If this link goes into dot state, so all these three cases, the IO will be redirected to another healthy CVM. Okay, I told the CVM resiliency, right? If one CVM goes down, what will happen? So hypervisor try to check, okay, whether CVM is reachable on this internal communication. The CVM is now that particular IP, right? What's IP? 192.168.5.2. This IP is down. So this IP is not reachable, then hypervisor, I mean, these information get updated in the routing table, and hypervisor what it does is look for another healthy CVM on another node. If there is a node 2 and that CVM is running, then this request will be now forwarded using the external switch, comes to the director, comes to the switch, and then goes to this host, and then it goes to the CVM. Okay, if the local CVM is available, then all the storage communication works on this local local switch, local internal switch, and local communication. If this CVM goes down and this IP is not reachable, then this IP is replaced by another CVM. Okay, other CVM public IP. In this case, 172.168. Okay, so we have ranges of 172, 23.30.30. Is next CVM public. That gets replaced. Okay, so now what my hypervisor does, it once it's a request from VM, hypervisor looks into that and informs, okay, my local CVM is down, so I have to take externally switch to route this traffic because I need to talk to this remote CVM 143. Okay, then this communication, because this virtual switch has no uplink, so the traffic will not leave this host. So whatever the traffic comes into this virtual switch are local. This switch has no uplink. When it's no uplink, it is not connected to any physical adapter, correct? So this traffic will not leave the local host. To leave the local host, you have to go to the external V switch and then adapter comes to the switch and then goes to the remote CVM. Okay. So now I can see in fairly short detail. Okay. So this is your internal switch and this is your external switch on host 1. Okay, then you have host 2, where you have internal switch and external switch. You have host 3, where you have internal switch, and then you have external switch. Okay, for external switch, we have adapters, uplink connector. Okay, and the internal switch has no uplink. I have a CVM. CVM has two interfaces. One is connected to the inter switch, and another one is connected to the external switch. Same here, CVM. Two interfaces, one connected to the internal switch, other one connected to the external interface. Okay. Now, so consider this is the internal. Okay, we are running VM. This is setting the request to the hypervisor. Hypervisor receives and using the internal switch. Okay, using the internal switch, this communication will be sent to the CVM on this local internal switch. Then CVM sends the request to the storage adapter. Okay, so this is how it works. But in case this CVM goes down, okay, now the traffic is going to this interface, right? So now this link is also down. So what it does, when this hypervisor receives this traffic, then what it does, it uses this external switch and this adapter, then comes to the switch, and then it goes to this adapter, this external switch, and then it goes to the CVM. Okay, every CVM maintains a local communication. Okay, the 192.168.5.1, right, is present in all the CVM. Okay? So all the CVM internal IPs, okay, CVM1 internal is 192.168.5.2. CM2 same IP 192.168.5.2. CV3 same IP. Okay, but there is no duplication because traffic never leaves host, right? It's internal. There is no uplink, so this traffic never leaves. The duplication will not happen. In this case, you cannot repeat the IP to multiple times, right? You can assume only one interface. But in CVM, it is an internal segment, so it is traffic never leaves this host. So all the CVMs will have the same IP as internal IP. Okay, so instead of I log into in a host to one, then from there I use to access my CVM. You can log into this host also, and then you use the same IP 192.168 SSH and 192.168.5.2. Then it takes you to the CVM. If you run this command from this host, then it will take you to this CVM. Okay, so 5.1 is the local local IP, and this subnet is present in all the hosts. If you have 10 hosts, it is present in the 10 hosts. So 10 CVMs, it has the same that too. Okay, so that's the CVM architecture. Okay, and second question here. Okay. So I said we have a host, then on top of that we have CVM, correct? Yeah, CVM, and we have two interfaces. I remember that one interface for local, right? This is connected to the interface, and we have something called external switch, and another interface is connected to this switch. I don't know this interfaces, right? But probably might have that question. So this is for inter-cluster communication. Okay, so I say inter-cluster communication CVM heartbeat. Okay, heartbeat or cluster related communication. Then your RF data, replication data, right? You write data there local, that data needs to be replicated to the remote nodes. So that replicated, that is automatically transferring over this interface. Then we have something called management. Okay. In management, we have reason, and then we have when I put this site, then we have GUI, and we have REST API. Okay, so we use CVM public IP to access GUI, access data, and access some SSH. Then CVM from your one host to other host, they need to talk to each other, right? So all that communication happening over the CVM IP. That public IP gets assigned here. So in our case, our cluster IP is our CVM is 172.23.30.142, correct? That IP gets assigned to this interface, and this interface is connected to the external switch. This external switch has the being connected, so your traffic will leave this host to this switch. Okay, so in CVM we have two interfaces. One interface is connected to the internal V switch, other interface connected to the external V switch. Okay, internal V switch is for internal communication. So what is internal communication? It is a storage communication. So it's between host and CVM. Okay, the external communication handles two different traffics. One is intra-cluster traffics, and then management traffic. So in intra-cluster we have CVM to CVM communication, cluster replication, then RF data, right? RF data transaction transmission. Then we have something called management traffic, and management we have some GUI interface. All that we are accessing over this interface. So if this interface goes down, I said, I already said, if this goes down, hypervisor and CVM will not be able to talk to each other, so then IOs will be directed to this one. But if this interface also goes down, okay, if this IP is not reachable, then what will happen? You will not be able to access your cluster over this, access your CVM over this GUI and REST API, and then RF communication to cluster start being seen, and then replicate RF data. So that all will have a problem. Okay. So these are the two different traffics leading this to this external switch and leaving this external switch. Okay. Any question in this area? Do you have any question? Okay. Okay, so we are good with CM interface and to internal switch, right? Next, we are going to talk about the physical adapter. Okay, so take one host, and then we have internal V switch. Then we have something called okay. Okay, this is internal V switch. Then we have something called external V switch. Okay, I said there are two interfaces where it gets connected to this external V switch, and this is your uplink. Okay, so how this two interface works? Okay, we have something called load balancing, or we have something called NIC teaming. Okay, or you can say port groups. Okay, or port channel, right? Or port channel, not port group, but it's port channel. So different term we use different terminology. Right? In Cisco switches we say port channel. In Windows we say NIC teaming. Okay, and then using this we will achieve load balancing. Correct? So all this gets applied here. Okay, consider you have a host 1. On this host 1 you have two interfaces, and these two interfaces are I mean, it is actually created as a bond. In HV we say bond, bonding. Okay, in Windows we say pairing. Okay, only the name is different, but concept of the thing is okay. So there is a bond created between these two interfaces. Okay, and in total we have 3 types of bonding. Okay, so the first active standby, or you can say active backup. Second one is balanced SLB, and third one we have is balanced TCP. Okay, these 3 are different load balancing or bonding that apply to these two interfaces. Okay, so I'll go one by one now. Okay, so first one, active standby. Okay, this is your host. We have internal V switch, and then we have external V switch, and we have two adapters. These two adapters are grouped together and using the concept of bond. Okay, so the active standby is the default bonding method. Okay, so who created this? Foundation. Okay, foundation itself we have this method created. Okay, no configuration required, or you can say no extra configuration required. So these are the it is a default configuration. Okay, and we don't have any requirement for this. Okay, no extra configuration, no special requirement. consider if this is a 10G pair. So you have two 10G adapters and that is grouped together and works on the concept of active and standby. So one interface is an active and another interface is in standby. So only one interface is active once. Okay. So if this is your active interface and this is your standby interface, then in an example, in a scenario where if your active interfaces go down and you have your standby interface, it becomes active because the active interface goes to down state, so the your standby interface comes into active state. Okay, so this is the behavior of active standby bonding method. Okay, so I said the two things: host level and VM level. So in host level maximum throughput, only one interface is active, right? Only one interface is always active because one is on standby mode, so one interface is only active always. So host level, one single interface is active. Okay, one single interface is active. So you get only 10G throughput at the host level. So coming to the VM level, so even the host level you get only 10G. So the VMs running on top of this host, right? So all the VMs will use this one interface to send the traffic, the external. So VM also gets only 10G throughput. Okay, I repeat. So active standby default bonding method. Okay, and only one interface is always active, so another interface is in standby mode. Okay, so in this scenario, if this is active, this becomes the standard once it comes online. Okay, so this is standby. So in a host level, only one interface is active always, so one 10G only active. So another 10G here, which is in down state. So only one 10G is active at the host level. So a host get maximum of 10G port. Okay, and this one interface can be used by all the VMs running on this host. So VMs also get only 10 GB throughput. Okay, so on a high level, host and VM both gets 10 GB throughput. Okay, so that's the behavior of your active standby. Okay, so then another difference here, you don't need to do any special configuration. Okay, so connect your normal switches, no recommendation or no specific requirement from switch side, no configuration required. Just connect your cable, just connect your plus nodes, and then you just do emailing. Okay, no recommendation or nothing is required. Okay, so it has very minimal effort. So it's very simple configuration. Okay, so advantages, you say a simple configuration. Okay, so probably you can say disadvantage, only one interface is active always. So you get only 10 GB throughput for both VM and host. Okay, so now we have second approach called balance SLD. Okay, so here we have this is your external switch. Then we have something called internal switch, right? And running on the host. We have two links. Okay. Now I'm taking these two interfaces and just making it big. Okay, interface 0/1. Okay, I will read 0/2, and this is 0/1. Okay, and these two are connected to it. You have switch 1, then you have switch 2. So one interface connected to one switch, another interface connected to switch. Switch the same like active standby, the same connectivity, no configuration, nothing related. It's a simple configuration from the switch side. Okay, from the switch side, you're not making any changes as this like active standby. But come to the CVM, okay, you have to talk to the CVM, of course. Okay, you have to change this load balancing because I said active standby is the default one. From there, you have to change it to balance SLB. That's the one change you need to make it. Okay, so then your host gets the balance SLB bonding. So this bonding is applied to these two interfaces. In active standby, I said one interface is active and interface is standby state. Here we said balance SLB. So how balance SLB works here? Okay, so again take the same concept, host level, VM level. In host level, these two interfaces are actually active. No standby concept. So both interfaces are active. So 10 GB and 10 GB. So you get 20 GB is active at host level. So host level, two interfaces are active. So host, so 10 plus 10 you get 20 GB throughput in the host. But earlier case, active standby, one interface always in the standby stage mode. So one interface is only active, so you get only 10 GB at host level, but you get 20 GB. In a VM level, okay, you have a VM, you have VMs. Okay, so if one VM uses this interface, another VM use this interface. Okay, so repeat again. VM can use only one interface at a time. Okay, so this VM cannot be sending the traffic to this two interfaces at one time. Okay, so if this is your VM 1 and this is your VM 2, if VM 1 uses this interface, then VM 2 uses the second interface. Okay, or you say that you have 4 VMs, VM 1 and 3 can use this, VM 2 and 4 can use this. There is no order like this, but we consider that VM can use only one interface at a time. It cannot send the traffic to two different interfaces. So VM can only use one interface, so it will get its 10 GB throughput. Okay, so I repeat again. We have two interfaces, and that is both two interfaces are active at host level. So most level I get 10 GB, action of that 20 GB I get. But VM level, if VM can use only one at a time, at one interface at a time. Okay, so this VM if start using this interface, it has to send the traffic to only this interface. It cannot share the load to another interface. This is not possible. So because of that, we are saying we can get only 10 GB speed at once throughput. Okay, 10 GB throughput at once. Okay. So here, no extra, no configuration required at switch level. Okay, no configuration required at switch level, but you have to change the load balancing from default active standby to balance necessary in the host. That one configuration you have to do it. Okay. The third one, okay, third one is balance TCP. concept, 2 switches, and this switch has 2 uplinks. External switch, internal switch. Okay, so in this, okay, consider the 2 interfaces, 0/1 and then 0/2. Okay. Then you have switches. Switch 1 and then switch 2. Here you have to connect these 2 switches. Okay, so there is a connection between these 2 switches. I mean, it actually works on spine and leaf switch concept. Okay, you have to place spine and leaf switch here, and now the switch is connected to this interface, and the switch is connected to the second interface. Okay, so both interfaces are active. Okay, when both interfaces host, if it is active, then host gets 20 GB throughput. Okay, so here 10 GB and here 10 GB. These are 10 GB interface cards, for example. Okay, so in total you get 20 GB. Next question is VM level. VM level, how much you get? In balance SLB, I said VM can only use one interface at one side, but here now see here you have a VM. This VM now send traffic to this interface, and it can also send the traffic to this interface. So VM1 use both adapters. So in total we get 20 GB throughput at VM. Okay, but how this will be used, right? So VM generates HTTP traffic, VM generates SSH traffic, VM generates FTP traffic, and VM generates DNS traffic. If different traffics might get generated by the VM, if how now how the VM distribute, right? So for HTTP, if it picks E01, then SSH it picks E2, then FTP it picks E1, DNS it picks E2. So each of the protocol it actually picks the interfaces. So okay, but remember one thing. So in this case, okay, I said FTP, then right. If only HTTP traffic is sent over to E1, right? So then this will not be distributed here. Okay, because if HTTP is going via E01, all the HTTP traffic from this VM is always using E01. Okay, but if SSH, if it is using E02, all the SSH traffic will be transferred to E0. Okay, so but VM can use both adapters, but it's the traffic based on the protocol. Okay, so we level host will get 20 GB. Okay, so to make it very simple, we have active standby, then we have balance SLB, then you have something called balance TCP. Correct. So here we have 2 interfaces, and then we have VM. So this is VM. Okay, this is active interface, this is standby. So consider ETH1/1, then ETH1/2. So VM1 is running. This VM can use only one interface. Okay. This VM can only use active interface. If there is 2 VMs, VM2 and VM2 also can use this active interface. Because this is only standby mode. So in host and VM you get only 10 GB throughput. But coming to the balance SLB, okay, we have 2 interfaces, then VMs running, VM1 and then VM2. Then we have interface called E1/1, then 1/2. If VM1 uses this interface, then VM2 uses the second interface. This VM never use both interfaces at once. Okay, it can only use one interface at once. So host level, two interfaces are active, so you get 20 GB. VM level, you can only use 10 GB. Coming to the balance, you have a couple of VMs running here, VM1 and VM2. So this VM generates different traffics, HTTP, DNS, SSH, FTP. So it depends based on the protocol. It actually distributes the traffic. If this VM, if it sends the HTTP traffic to it 1/1, then it always sends this traffic to this interface. For DNS, you pick the second adapter. Okay, so now we can use both interfaces. I mean, you can share the load between these two interfaces. So VM can contribute, or we can use both adapters. We can also get 20 GB in this case. Here, both VM and host get 10 GB, but here the host gets 20 GB, but the VM only gets 10 GB because one can use only one interface at a time. It can only connect only one interface at a time. Here, we can connect to both the interface, but it splits the traffic based on the protocol. Okay, so you get 20 GB in both VM and host. But advantages, if you see here, this is a very simple configuration and it is a default configuration. No extra work. Here, you have to only change the load balancing or bonding method. But this is since and it is same like this, no extra configuration required. Switch level, no configuration. But here you have to pay sign and leave concept. So you have an investment on this networking switch level, physical switch level. Okay, and it is a complex configuration because you have to enable load balancing on both switch level and the host level. Okay, so on this two interface, you have to configure load active, and on a switch level also you have to configure. So it is a complex configuration. If you have this, you get maximum throughput. So you have any questions for us now? Is it clear? Okay. Yeah, hi Subramanian. Yeah, but you cannot understand anything because we have covered most of the things. Okay.
Just listening.
Okay. So we actually covered, I mean, on a high level, I can repeat. So we have two different V network. One is managed and one is unmanaged. It is similar like a port group we create in VMware. Okay, so for any VM, we have port group, right? So that purpose, they have two different networks. So one is managed and the second one is unmanaged. In the managed, it automatically assigns the IP address to the guest VM. So you have to provide the range in that VM network, and whenever you create them, you have to go to a particular port group and assigns IP address automatically to the VM. Unmanaged is something you have to manually assign the IP address, but it maps the right VLAN to the VM. But assigning the IP address is up to the user, so you have to go and manually assign the IP address. So these two are the different groups or VM network we say. Okay, so VM page, we have network configuration. Here we have to define. So we created manage, and then we have created and so for manage, I have provided the 100, and then I have provided range here. Subnet I have provided, and then a pool I have created. So from 100 to 200, I have provided this. Now what I have to do is I go back to creating VM. Okay, I have to select the network card, and then you have to define which VLAN it needs to be verified. So you have to pick it. With the VLAN 100, so VLAN 100 is managed, and then VLAN 200 is managed. So you have to pick VLAN 100 managed, then you can add it. So I have attached one network card, and that is part of VLAN 100, and it is the managed network. So it gets IP address automatically. I don't need to manually assign the IP to this VM. Okay, so that on what we have seen, and then CVM in host we have two V switches. One is internal V switch and then external V switch. This internal V switch is only used for hypervisor to CVM communication, okay? And that is for the storage communication. It depends on the hypervisor. The storage protocol will be chosen. If it is HV, ISC, if it is VMware, then NFS. If it is Hyper-V, then SMB protocol will be chosen. This is the internal communication. This switch has no uplinks. Okay, so this traffic will never leave this host. It is only internal communication. And our IP address is 192.168.5.0 is used for this internal range. Okay, I have actually shown that into the lab, so probably you can watch the recording. So this switch only for the internal communication. 192.168.5.1 is the hypervisor IP, and 5.2 is the CVM IP. So CVM in CVM has two interfaces, two virtual interfaces. One interface will be used to connect to this internal switch, and another interface will be used to connect to this external switch. There are two interfaces for internal and external switch. This internal application is only for storage traffic. This external switch connection is for different purposes. One, management, RSS, HTTP shell, then GUI, all that traffic is sending over this link. When you enter Prism ID on the browser, with this interface, we are reaching CVM. And then second, CVM needs to talk to other CVM, and it also needs to send the replicated data, RF data to other nodes, right? So those traffic is going to this interfaces. So there are two communication. One is inter-cluster communication, and second one is management communication. There are two communication that is the external switch. This external switch has the uplink. This uplink is the physical address connected on that host. And then on these two interfaces, we have something called bonding, or you can say knitting, or you can say port channel. Okay, but in H we say bonding. So bonding gets applied. So totally different bonding available. One is active standby. This is the default method, and then we have something called balance SSB. The third one is balance TCP. The active standby is a very simple configuration, but you get a minimum throughput. But balance TCP is the advanced configuration and complex configuration. It requires an extra investment on the physical switch level. Okay, you have to unit the stylish switches on the data center, but this gives maximum throughput. Okay, so these are the areas we actually cover. Okay, so, but in a go to the recordings, and if you have a question, probably we can discuss next. Okay. 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 So next, we said we have covered manage and unmanaged network, and we have covered bonding. Okay, So next we're going to see network segmentation. Okay, so if you see, I said you have a host. On that host, you have internal vSwitch. Then you have external vSwitch. Okay. So on top we have CVM. CVM has two interfaces. One interface connected to this internal switch, another is connected to external switch. Then we have link adapters. This gets connected to the external switch, correct? And then we have node 2, node 3. Okay, but this is the node 1. And in every node we have a CVM only. Okay, so now we are clear with this area. This is only for the internal communication, internal storage communication. Okay, internal communication. Okay, so coming to this external communication, I said there are two different traffic. Okay, so one I said management. On management, your GUI, SSH, then your REST API. Then second one, we have something called intra cluster traffic. So here your CVM to CVM communication, then intra cluster, and duplication RF, then HT. Okay, so all that traffic is going over this intra-cluster traffic. These traffic are using this interface. Using this interface, two traffics are traveling. Okay, so now, so whoever wants to access microserver, they use the same interface IP. They use the same interface IP, and they this is external traffic, right? So they access the IP. Using this IP, they access my prism. And other traffic, which is the critical or secured, it needs to be secured. Those traffic is also running over this interface. So there's a check mark on the security side. So if both traffic is running over this interface and anybody has my client can access this interface, and there is a question for security part. What happens if something goes wrong with this interface? They can hack the traffic. Okay, so that's the question raised by customers. So I mean, I don't want these two traffics go in this single interface. Okay, I need extra security here. So why don't we have a third interface created, and that interface handles the intra-cluster traffic. I leave the management with this default interface, but take away the intra-cluster traffic and put into a different interface. Okay, so this adds extra security because nobody disturbs this traffic. It goes in the separate interface. So if whoever wants to access some REST API or SSH, they use this interface IP, they connect it, and the interface traffic goes over this adapter. Okay, so it is a segmentation. They're segmenting the traffic. Say micro-segmentation. Okay, so same kind of concept, but we are segmenting two different traffics. So there are two different traffics which run over this interface. But customers say, I don't want to run. I don't want to have a single interface for two different traffics. Why don't we have a separate interface which handles the interface traffic? Okay, so this concept is the network segmentation. Okay, so now what is we have CVM. In CVM, we have 3 different interfaces. Okay, by default, you have these 2 interfaces. This one extra, you get it. Okay, and I said there's 2 internal switch. Sorry, I said 2 switches. One is internal and one is external. Right? So this is connected to internal switch, storage, communication. Okay, we are not going to touch this. Don't touch this. Okay, that's a high recommendation. So we are actually going to open these 2 interfaces. So by default, both management and intercluster traffic on this interface. Now I put a additional interface and I segment traffic. So now intercluster traffic moves to this interface, and even this interface connected to this external switches. So now who wants to access the prism, they use IP added to this interface, and intra-cluster communication is happening over this interface, and it goes to the other node, and then we see them, right? In every CV, now we have the interfaces. Okay, so that's the concept of network segmentation. Okay, so this cases we actually divided traffic into interface, but finally you see both are coming to the same switch, same external switch, and then coming to the same adapter. But now you can add an extra concept here, like you can add one more switch, and then you can put the traffic into this, and then place extra interfaces, and then go to another CM. So now it is completely segmented. Okay. So earlier segmentation applied only on CVM level, but makes no sense because finally it is going to use same switch and same interface, and all traffic is coming to the same bucket, right? So that really that does not add any security. But later, what they have done is now you have the extra switches created, and then that switch will have the updates. So your intra-cluster traffic is coming to this switch, your management traffic is going to this switch. So at every lane you have added the segmentation. Here. Okay, so moving back to presentation. Okay. So I said managed and unmanaged. In managed, we have interest managed to via DHCP pool. Then management, unmanaged, we have to assign interest manually. The DMs directly connect to a VLAN. There is no address allocation. Okay. So how does using the IP concept is IP management? So VMs request, and in HP it is actually I have separated the EXN. So EXN is the extended VLAN. Then it is forwarded to the master. Acropole is master. So whoever is master, Acropole is master. Which CVM is Acropole is master, right? That hosts the DHCP server. I have shown you we have an option to override the DHCP server. So where DHCP server gets assigned, so that is assigned to the Acropole master, and that master response, and it responds back with the IP address. So now the VM gets IP address. Okay, so we are sending the request immediately, that is encapsulated into the VXLAN, and that is sent to the DHCP server. Who is DHCP server? Acropolis master. Okay, Acropolis is the server service which is running on the CVM. So which CVM hosts the Acropolis master, that also hosts the DHCP server that receives the and then it responds with the IP address. So now finally the VM gets IP address. Okay, So see here, this is Acropolis save and this is Acropolis master, this CVM. So now we are running on here, needs the IP address, so it's send the DHCP request. It is encapsulated as a DVX LAN, and then it immediately checks who is master, Acropolis master. Then the Acropolis request is forwarded to the Acropolis master. So this master is actually hosting the DHCP, so immediately responds to DHCP IP. Okay. So come back to this network segmentation, but then moving to the CVM interfaces, internal vSwitch all that I told, right? CVM has two interfaces, E0 and E1. E0 is for the external purpose. E1 is for the internal. Okay, so you get 5.2 and 2.4 IP for the CVM. Then we have two vSwitches. In HV we say bridges. Okay, virtual bridge 0 and BR0. Okay, this BR0, this is the internal message, and this has the HV host is connected. I read this HV and CVM connect to this virtual bridge 0, and all storage communication between CVM and HV host is happening over this way. Then this BR0, it has the plane bond method, so that CVM external traffic goes over. So intra-cluster traffic and management all use this 0 and come here. This is before network segmentation. Okay, and if we go after network segmentation, then we have a separate third interface gets created, and now all intra-cluster traffic comes into this E2. Okay, so here it is on the section. We switch NUTANIX. This is the internal storage, and store in ESX host we have kernel adapter gets created and hosts this IP. This is for the storage IO switch. Then we have some called store V0. This handles the management switch, and this is for the both interruption and interruption and management traffic. Okay, then third switch we created, this is a recommendation. Okay, you can handle this or you can use this switch. So you wanted to keep your guest switch traffic to go into a separate vSwitch, then go and create a separate vSwitch for web guest VMs. And that needs the uplinks, so you can place the uplink. In this design, we have placed one vSwitch for both intra-cluster traffic and management traffic. The segmentation is applied only on the CVM, not on the switch level and the adapter level. This is the old design, but now this E2 itself will have a separate vSwitch, and E0 also will have a separate vSwitch. Then for guest VM, that we will place a separate vSwitch. So in total, you get 4 vSwitches. One vSwitch for the internal, one vSwitch for management, and another vSwitch for third vSwitch for infrastructure, then fourth vSwitch for guest VM traffic to guest VM to complete. Okay. So this is the latest one inside, right? So you get vSwitch NUTANIX. This is for the internal communication. This is for the management traffic, and we have E2. This is for backplane traffic. So when you say backplane, that's infrastructure traffic and your CVM communication, right? So that all is backplane traffic. So management traffic. Backplane is a different name I use. We same concept like intra-cluster traffic. So on the backplane, we have intra-cluster traffic, replication, and then HTTP. So it uses a separate vSwitch here, and I have a separate physical links. And then you have something called vSwitch 1. This is probably using for the CVM. But here they have connected this to CVM, probably for the volume service. Okay, so this is another service volumes, and we used another separate traffic for this volume service. I talk about this data. Just give. Okay, so Okay, so network segmentation, if you see, all gave a great back traffic. Okay, so all the I mean, see other actions. If you see, if you wanted to perform AOS upgrade, you can, I mean, you can perform the AOS upgrade if it is already segmented. Okay, if not segmented, I mean, difference here is if you go with the old AOS upgrade, if you are running older AOS, you have the as it is. But nowadays, this Ethernet to interface is default created, but it is not configured. You can configure that later. I'll show you where to do this configuration. Okay, so we have to come to the same video when we create the network. Come to the internal interface. Okay, so we see here there are three interfaces. Okay, so come from bottom, we have management. That's for the system and REST API. That is E0. Then we have hypervisor LAN. This is for the internal communication. The third one is the backplane. Okay, so backplane is actually used for traffic others. Okay, if you click this, see here the interface is already created. Earlier case, some cases we have to manually create. Now we have to configure it. Okay, it will ask you for IP address. You have to go to the new subnet for this. Okay, so you have to take different subnet and you have to enter this IP, subnet IP, not necessary to enter the IP address. So if you provide the subnet and from there it automatically picks the IP for every CVM and then configure this interface on all the CVMs. If you have 10 more clusters, so you have 10 CVMs in each and every CVM. This interface needs to be configured, but we are not going to configure this on each and every CVM. So you do it at one single result. You provide the subnet ID, and from the subnet it picks the free IP and it does it to the each and every CVM. Okay, so that's the behavior of network segmentation. Okay, so any question here on network segmentation?
No.
Okay. Okay, so then to the so this 192.0 sum, right? You can actually read this. Okay, but I have already explained it. This is only for the CVM and host communication, right? So it is associated with the private network on the default VLAN and uses this address. This traffic is restricted to the internal switch. Might be sent over the physical right through the host route to implement the Hyper-V26 and Hyper-V cluster. So this subnet, if you have any plan to use in your data center, so NUTANIX says that in such circumstances you try to avoid this subnet. Okay, but if it is not something, I mean, if it is really required, probably you can go for it. The recommendation would be don't take this subnet in your data center for any infrastructure. Okay, NUTANIX says that this traffic number lives, but some cases like here mentioned in ES6 and Hyper-V cluster, and some cases traffic might leave the host. So it's better to avoid the duplication. Don't use this subnet in your data center. Okay, but if it is HP, no issue. But other cases, the recommendation would be don't take this subnet in your data center. Just leave the subnet for the NUTANIX signal communication. For SVMs and other devices on the net that overlaps with the 5.0.24/700 on the default VLAN. If you want to use the overlapping subnet for such devices, make sure that you use a different VLAN. Okay, so probably change the VLAN ID. So here it's mentioned that you use the default VLAN. So if you wanted to go the probably if there is a need to use the subnet, then go with the different VLAN ID. Okay, and in each we have different ports, internal port, tap ports, and then VXLAN ports. If you see here, all the user VMs having the tap ports. Okay, but if you see here, the BR0 and then I'll take one more. Okay, see here, this VNet 0 and VNet 1, right? This VNet 0 and VNet ports are only for the CV. Okay, tab 0 and tab ports are for disk VMs. Okay, and BL0 it is similar like kernel adapter ports. In VMware we create VM kernel ports, right? So it is BR0 and BR0, BR1, all that are actually kind of kernel adapters. Okay, VNet0, don't say VNet0, so it is VNet. Okay, so VNet interfaces are used by CVM, tap interfaces are used by SVM, and BR0 is common. It is connected to these switches. Okay, so we have some network visualization. If you wanted to see the complete flow, we don't have that email with us because we have not configured network visualization here. Otherwise, if you configure for the requirement for network visualization, you need to have the switch your data center layer switches, right? That needs to be added. Then SNMP configuration needs to be configured. If you have that configuration here, then what you can do is you can come back to the network. Then you can see your physical. Here I have one VM that is connected that is running on this host, and this host has one interface E0, speed of that is 10 GB, and then on the switch side I don't have any information. See which interface it is connected, all I don't have data is unavailable. To get data, you have to add your switches. Then you have the NPN information like on which port my host is connected or this level. Okay, so you get to know the MAC address and all that information. You can get it in the same screen. Okay. And last, we have one method active backup balance will be balance TCP with ACP. Okay, so balance active backup. So only one interface is active, so it is connected to two switches. We have interfaces, and all the traffic is going over the one interface. So one interface is active, and another one is on the standby or backup purpose. Okay. Then load balancing balance SLB. Both interfaces are active, but if VM1 use this connection, then VM3 use this connection. VM can only use one connection here. We cannot use both the interfaces at once. Okay, if you go to balance SLB, then it can use actually both interfaces. The one comparison, in H we say actually bridge, but in VM we switch or distributed switch. On Hyper-V we say virtual switches. We say bond, and VM we say team, and in Microsoft we say team. Okay, ports. In H we say V network or network, but in VM we say V port. Here we say uplink, there is physical link or VM link. Okay, internal port, VM kernel port, active backup, standby. Balance SSD, then we say VM route based on source MAC hash bandwidth, or based on physical link load. LACP with balance TCP, in VM we say LACP with route based on IP hash. Okay, so only the names are different, but content-wise everything is same. Okay, so if you have the lab session, you can go and check the. If you have a lab, you can go and do the some configuration. But this bonding we can configure in the lab environment, because the third requirement, right, balance TCP, is actually required switch level, and you need the switches. I said that is only possible in the production environment. But for this, even this active backup and balance SLE, in our lab, we are running a single node cluster, so this not be created. But generally, we questions on these three, so they will ask you to differentiate these three one method, okay, and ask you to talk about advantage and disadvantages. Active backup, you can say advantage, it's very simple. No extra investment required, no extra configuration required, it is default configuration. But the disadvantage is we can only get 10 GB throughput, okay, VM level, and host level also 10 GB throughput. With the balance SSLB, it is same simple approach, no extra investment required on the switch side, no extra configuration on the switches side, but one configuration you have to do it on the host level, that you have to change the bond from active backup to balance SSLB. Okay, if you change it, in host level you get 40 GB, but VM level 10 GB. Okay, the advantage here is you are providing a maximum throughput of your host. Okay, so that advantage you get, but another advantage is you are getting throughput 20 GB at host level without any investment, or much, and without any complex configuration. The problem here is still a VM only get 10 GB throughput. Third approach is the balance TCP. It is the most advanced configuration, and it gives more. It gives the better. Not better. It gives maximum performance. The problem is you require extra investment on the switches level. If it is a legacy switch, you have to replace your legacy switching environment to spinal leaf model. Then the ASIC needs to be configured at both levels, switch level as well as host level. If you make a misconfiguration at any level, then the whole configuration collapsed. Okay, but there is a failover when you have the problem of with this LCP configuration, then your interface goes into standby mode. Okay, because you have two interfaces connected here, and VM sends traffic to both interfaces. But it's the traffic based on protocol, HTTP, SSH, DNS, FTP. But if one interface goes down, then all the traffic will be using one interface, because one interface is already down, so you can use one interface. So that is flexibility you have with the balance TCP. So if they ask you on a high level, you say you get maximum performance with the balance TCP. That's the complex scenario, and it also requires extra investment. So you have to talk about that. Okay. So these are the important areas from networking side. Okay. So you get questions from network segmentation, you get questions from bonding. Okay. So these are the two areas you get. Segmentation, it is the major part, and then bonding. Okay. Manage, you get exam questions, but interviews is very rare to get questions from this area. Okay. So any questions? Okay, so we have covered manage and item. We switch implementation with load balancing, then network implementation. Do you have any specific questions on this area? If you are not clear, then probably you can ask me. Still have time. Okay, so we can cover up the we can recall, we cover up any areas.